Hello everyone, welcome to 𝗏𝗍𝗃𝗃 YouTube channel, your one-stop solution to ACE interviews. In this video, we will be discussing first four problems of deep 4 latest Codechef contest named 179. So without wasting any time, let us begin.
So let's start with the first problem. Conquer the fist. I want you guys to go ahead and read the problem statement. If you understood the problem statement, I want you guys to go ahead and code it up. If you did not, it's okay. Anyhow, we'll be discussing the problem statement. Let's start with the first problem. 𝗟𝗲𝗃𝗃𝗃 Pune is celebrating its annual fest with a lineup of exciting events, and among the technical events, Infinity stands out as a prestigious coding contest known for its challenging coding problems. This year, the contest includes difficult problem. The problem has difficulty level of B, and the participants need to have an IQ of at least 10 into B to solve it. You have an IQ of N. Can you take on the challenge and solve this tough problem, or is it too hard to crack? So in the problem, they said that there are some participants who is going to participate in a contest, and in the contest, you'll be asked a question which has a difficulty of B. Now, to solve this problem, you need to have an IQ of at least 10 into B. Only then you can solve this problem. Now, the problem says that the participant initially has an IQ of N, and you have to simply check whether the participant is able to solve this problem or not. Now, how can he solve this problem? He can only solve the problem if he has an IQ of at least 10 into B. What does the B stands for? B stands for difficulty of the problem. So what will I do? I have to simply check whether the IQ of the person is at least 10 into B or not. So what will I do? I'll simply put a if condition. I'll simply say if the IQ of the person, which is N, is greater than or equals to 10 into B. So this is the minimum IQ level required to solve a problem which has a difficulty of B. So if the IQ of the person is at least equals to or greater than the 10 into B, I'll simply say yes, is able to solve the problem. So let's see what we have to print if is able to solve the problem. Let's look at the output format. The output format says simply print yes if is able to solve the problem, or no if it's not. So I'll simply say print yes, else if the condition fails. If this condition fails, what does it mean? It means that the person cannot solve the problem with an IQ of N. So I'll simply say print no. That's it. Let's go ahead and code it up. Alright, let's code it up. We know the input format. You're only given N and B, which are the IQ and the difficulty of the problem. So let's take the input of N and B. Now what is the condition? I have to simply check, put an if condition and check whether the IQ of the person is greater than or equals to 10 into B. If that's the case, I have to simply print. So I'll simply say cout. I'll print yes. I'll print a new line. Else I have to simply print no. Let's run the code. Let's look at the sample input. It says yes, which is the expected output. Let's submit the code. Yeah, the problem got accepted. So the people who did not code it up, it's the time, go ahead and code it up. Let's discuss the second problem. Lost in the fest. Bhumi was excited for the annual fest at 𝗟𝗲𝗃𝗃 Pune. She found a spot in the queue, eagerly waiting for the performance. But there was a problem. Tall students had blocked her view. Frustrated, she wondered, how much do I have to move to be able to see the performance? There are N students who want to watch the performance at the fest. They're standing in a straight queue. And the ith student in the queue has height of HI. A student will be able to watch the performance if and only if they are strictly taller than every student ahead of them. That is, student I will be able to watch the performance if and only if h of I is greater than h of j for all the values of j. Now, Bhumi is the last student in the queue with a height of hn. Every second she can swap places with the person just in front of her. That is, if she is currently at the position I, she can move to the position I-1, and the person previously at the position I-1 can move to the position I instead. How many seconds will it take Bhumi is she able to see the performance? Let's see the problem statement. Let's understand the problem statement. So there's a performance going on in the triplet and Pune. Let's say this is the performance, and there are n students standing in a straight queue. Let's say this is the queue, and let me represent the positions with numbers 1, 2, 3, 4, 5, 6, and 7. Now, boom is the person standing at the last in the queue. That is at the nth position. Now, in the problem, they said that if a person is standing at the ith position, she can only watch the performance if her height is strictly taller than all the students ahead of her. Now, if the height of Bhumi, let's say Bhumi is standing in the 7th position, and if the height of the Bhumi is actually greater than all the students standing ahead of her, only then she can watch the performance. Now, I cannot give a guarantee that all the students' height will be taller than Bhumi. No, there might be a case where the 4th person is actually taller than Bhumi. No, this person is actually blocking the view of the Bhumi. No, so she wants to watch the performance. So what she will do? She will come to this position, but she cannot directly come to this position. There is a condition that at every second she will swap her position with the student ahead of her. That is, let's say student Bhumi is at the 7th position. Now, since she cannot watch the performance, what she will do? She will swap her position with the 6th student position who is standing at the 6th position. So Bhumi will come here. Now Bhumi will be here. Now still she cannot see. So what she'll do? She'll again swap her position with 5th student. Now even after swapping 2 times, she's still unable to see the performance. So what she'll do? She'll swap the position again with the 4th person. Now the moment she comes here, let's say all the students here are having height less than Bhumi. So now she is able to watch the performance. Now how many seconds did it take for her to come till here? 3 seconds. So this is the time taken for the Bhumi to reach the 4th position from where she can watch the performance. Now this is the problem statement. They're asking you to find the number of seconds it takes for the Bhumi to come to a position where she can watch the performance. Clear? Let's try to understand the problem statement with an example. Let's look at the sample input. So in the test case 1, there are 6 students, and of course Bhumi will be standing at the last in the queue. So let's say this is the performance. Can Bhumi watch the performance? No. She have to come to this position to watch the performance. So how many seconds will it take for Bhumi to reach here? I know that at every second she can only swap with the position ahead of her. So she'll come here for the first second, then she'll come here for the 2 seconds, then she'll reach here after 3 seconds, then she'll reach here after 4 seconds. So it takes 4 seconds for Bhumi to reach here, which is expected. Now in the test case 2, does Bhumi have to change her position? Not required, right? Because Bhumi can start watching the performance straightly from this position only, because all the students ahead of Bhumi are having height less than Bhumi, so she can watch the performance. There is no need of swapping. So it takes 0 seconds to start watching the performance. Now in the test case 3, can Bhumi watch the performance from here? No, she cannot. Why? This person will be blocking the view. So she have to reach here to start watching the performance. So how many seconds will it take from here to here? So for the first second, she'll reach here. In the second 2 seconds, she'll reach here. In 3 seconds, she'll reach here. So it takes 3 seconds for Bhumi to watch the performance. I hope you understood the sample input and output as well. Now, I want you guys to come up with the logic. If you did come up with the logic, go ahead and code it up. If you did not, it's okay. We'll anyhow be discussing the logic. Now, in the first test case, where should Bhumi reach? Bhumi should come to this position to watch the performance. Bhumi should come to this position to watch the performance, and Bhumi should come to this position to watch the performance. What are these positions? These are the position from the beginning where she can watch the performance. Now, this position is nothing but it is the first time we are encountering a height which is greater than or equals to height of Bhumi from the beginning. So similarly, even this is the first height we are encountering from the beginning where the height is greater than or equals to the height of the Bhumi. Same case for here as well. Now, I found the position. Now I know initially Bhumi starts from here. Bhumi starts from this position. And for the first case, she have to reach here. So let me write the indexes. We know that heights are given in an array. So let me write the indexes. 0, 1, 2, 3, 4, 5. Now Bhumi have to come from 5th position, let's say 5th index to 1st index. Now, how many students are there in between? There are, can I say, 1, 2, 3 and 4. 4 students. So which is nothing but, can I simply say fifth position minus 1, which is 4. There are 4 students in between. So she need 4 swaps to reach index 1. So I know that at each swap it takes 1 second. So it takes 4 seconds for Bhumi to reach from 5th position to 1st position. Similarly, initial position of Bhumi for this test case is 4. Now what is the required position where Bhumi can go and watch the performance? 4. So how many positions are there in between? 0. So how many seconds will it take? 0 seconds, because we are not doing any swaps. Similarly for this test case, let me write the indexes 0, 1, 2, 3. Now for this test case, Bhumi's current position is at index 3 and Bhumi have to reach index 0. Now how many swaps do I need? 3 swaps. So for each swap it takes 1 second, so it takes 3 seconds. Small change. Here we are having index 3. Index 3 is the last position. So 3 is the start position of the Bhumi and 3 is the destination position. So 3 minus 3 is 0. So I don't have to do any swaps. So simply 0 seconds. We have to simply print 0. I hope you understood. So we are simply finding the first position from the beginning where she can watch the performance. So what should I do? I have to iterate on the array. First step is to iterate on array from the beginning. Now, when should I stop? Stop if array of I, if current position is greater than or equals to height of Bhumi. Then find the answer. Answer is nothing but, what is the position of the Bhumi? Bhumi's position is nothing but n minus 1. And what is the position which we found? Let's say position is POS. So this is the answer. It takes these many seconds for Bhumi to start watching the performance. Alright, let's go ahead and code it up. So let's code it up. Let's look at the input format. You're given T, the number of test cases, and in each test case you're given an n, the number of students, and the second line contains n spaced integers, which are nothing but heights of the students. So let me take the inputs. So first is T, the number of test cases. Then I'll run a while loop for the test cases. Then in each test case we're having two lines. One is the number of students, which is n. Then let's take the heights of the students and store it in an array. So I'll take an array of size n, I'll iterate and take the inputs. Now I need a variable to find the position from where Bhumi can watch. So I will take POS. Now I need to iterate on the array from the beginning. So I will iterate on the array. Now what was the condition? So at any moment from the beginning, if I find a position where the height of the current position is greater than the height of the Bhumi, then I need to take that position and break from the loop. So if heights of I is greater than or equals to, so what is the height of Bhumi? Where does Bhumi stands? Bhumi stands at the last in the queue. So that means she's at the position n minus 1. So at any moment, if the current height is actually greater than or equals to the Bhumi side, then what will I do? I'll simply say position is equals to I, then break from the loop because I found the position. Now I found the position. What is my answer? Answer is nothing but, it takes n minus 1. Since we are moving from n minus 1 position to position, so it takes n minus 1 minus position swaps, so which is nothing but the number of seconds, because in each swap it takes 1 second. So I'll simply print the answer. I'll print a new line. Let's run the code. So the outputs are matching for the sample test case. Let's try to submit the code. Yeah, it got accepted. So why are you waiting? Go ahead and code it up. let's discuss the third solution, unlock the safe. Chef has a safe with n dials. The ith dial initially shows the digit AI. To unlock the safe, the digit shown on the ith dial should be B of I. In order to achieve this, Chef can choose a dial and perform one of the following two moves. Up move, increase the number on the chosen dial by 1. If it is 9, then it becomes 1. Down move. Decrease the number on chosen dial by 1. If it is 1, then it becomes 9. In order to not to seem suspicious, Chef thinks he has to use exactly k moves to unlock the safe. Is it possible for Chef to unlock the safe while performing exactly k moves in the process? Note that Chef is allowed to reach the target digits even before the k moves. However, even if it does, he must still continue making moves till he has made exactly k moves. It is not allowed to stop before that. See the examples case below for more clarity. Now let's try to understand the problem statement. So here having a safe which has n dials. So let's say initially there are numbers on these dials. Let's say the initial dial numbers are A1, A2, A3, so on till AN. Now the safe can only be unlocked if the numbers on the dials are B1, B2, B3 and so on Bn. So if the numbers on the dial are this, only then we can unlock the safe. But initially the numbers on the safe are this, because if we lock the safe, what do? We interchange the numbers so that the actual digits to unlock the safe will be changed. So initially you're given a safe on which the dial numbers are this. Now you have to convert this to unlock the safe. Now to convert these numbers to these numbers, we are having two operations. One is up operation and another is down operation. Now let's try to understand these operations. Let's take a number. Let's say you're having 3. Now we can perform up operation to convert this 3 to 4. That is, you are simply incrementing the 3 by plus 1. Now you can also perform another option, down operation. That is, you can convert this 3 to 2 by decrementing the number. Now in the question it stated that if the number is 9, we can perform up operation and convert it to 1. So that means each dial can have numbers from 1 to 9. Now let's say AI is 9. Now if we perform an up operation, it doesn't become 10. Instead it becomes 1. So do you understand that it is a circular dial? That is, if you do an up operation on 9, it becomes 1. So one operation you can convert 9 to 1 in the up operation. Similarly, in the down operation, you can convert this 9 to 8. So clear? So these are the operations you can perform on the dial. Now what do we have to find? We have to do exactly k operations such that we can unlock the safe. Now when can we unlock the safe? When all the initial digits gets converted to the required digits, only then we can unlock the safe. So one operation is nothing but if we increase a number, if we do a up operation once, it becomes plus 1. So that is one operation. If we can also perform a down operation, that is, we can decrement the value by minus 1 and perform a down operation. Now by using these operations, we have to simply check, can we convert AI, the initial dial, to the required dial in k number of operations. So clear? Let me give an overview on it. So initially we are having this on the dial. So we are having this dial, the initial dial. We have to convert this initial dial to the final dial. Only then we can open the safe. Now to convert these numbers to these numbers, we can apply two operations, up operation and the down operation. In the up operation, we can increment the value. We can move forward and by incrementing the value by 1. Similarly, we can also perform down operation. If you perform a down operation, the value gets decremented. Now this is a circular dial. That is, if you perform an up operation on 9, it becomes 1. Now similarly, if you perform a down operation on 1, it becomes 9. Now we have to perform exactly k operations on the initial dial and check whether can we open the safe. When can we open the safe? If after performing the k operations on this initial dial and all these numbers gets converted to all these numbers, only then we can unlock the dial. If we unlock the dial, we have to simply print S. If we cannot unlock the dial, we have to simply print no. Clear the problem statement? Now let's try to understand the problem statement with an example. Now let's take an example. Let's say I want to convert 2 to 7. Now I can perform one of the operation So one operation can be up operation, it takes 5 moves. And down, if I take the down operation, it will simply be 9 minus 5, which is 4 moves. Now let's say I want to convert 8 to 2. Now if I do up operation, how many operations will it take? I'll convert 8 to 9, then 8 to 9, then 9 to 1, then 1 to 2. So it will take 3 operations. Down operation, down will take, so 8 to 7, then 6, then 5, then 4, then 3, then 2. So it will take simply 9 minus 3 operations, which is 6 operations. So 9 minus 3, which is 6 operations. Now, let's say, let A of I or B of I be any values. Let's say AI and BI. Now it can be any of the values. Now, one move will definitely be difference of AI and BI. I can simply take ABS. So if you take closely, this is AI, this is BI. The difference will be 5 if I take the ABS. Similarly, same here as well, the difference is 6. Do you understand that one of the move will be the difference between these two values? No, other move will be simply 9 minus ABS of A of I minus B of I, because the leftover moves will be the other move, other operation. So the two operations can be, operation 1 is ABS of A of I minus B of I. Then operation 2 can be simply 9 minus operation 1. Now we know we can perform these two operations. Now let's construct the logic. Now let's say I'm having values. Let's say I'm having an array. Let's say 2, 4, 6, 3, and I want to convert this to 1, 5, let's say 7, let's say 2, and 9. Now, first step, I'll forget about the k. Let's say my k is 15. Let's forget about the k. Let's not worry about the k. Let's first try to find the minimum number of moves required to convert this A to B. Let's say this my A is initial dial and B is the required dial. So let's find the minimum number of moves to convert this A to B. So here, what is the minimum? So one operation could be, operation will be different, that is 1. Then operation 2 will be 8. Then here the operation 1 will be 3. Then operation 2 will be, so 7 minus 4 is 3. Then operation 2 will be 9 minus 3, which is 6. Then operation 1 here will be 6 minus 2, which is 4. Then operation 2 will be 5. Then here operation 1 will be 6. Then operation 2 will be 3. Now, what we are trying to construct? We are trying to take the minimum number of moves at each dial. So, let's take the mini. So, here what will you choose? Will you choose 1 or 8? I'll try to, of course, go with the minimum possible values. So, I'll take 1. Then here I will take 3. Then here I'll take 4. Then here I'll take 3. So, what are total moves? What are total minimum number of moves to convert A to B? 6, 10, 11. So I need at least 11 moves to make A to B. Now let's come back to the K. What was the K value? Now K was 15. Now let's say my minimum moves was not 11, it was 20. Let's say it was 20. Now if my minimum number of moves to convert A to B is 20, then is it possible for me to convert A to B with K as my 15? No, right? If minimum itself is 20, I can never convert A to B with K as 15. So I'll simply say, no, I cannot convert. Now let's come back to the same problem where my minimum is 11. Now let's also take another case where my minimum moves is 15. Now let's say my minimum moves is 15. Can I simply say I can convert A to B with exactly K moves? So in that case, what will I do? I'll simply print yes. Now the other case would be where the number of moves, the minimum number of moves to convert A to B is less than K. So if, let me write these three cases. If min is actually greater than K, so output would be no. Another case would be if min is equals to exactly number of moves, which is true. So I'll print as. Now other case will be if min is greater than K. Now here comes the difficult part. Let's stick with the same example. What was my min? My min is 11 and my K is 15. Now what is the difference here? Now difference here is 4. Now I'm having I need to do 4 extra moves and check whether I can convert this A to B or not. Now if let's say I perform this 11 operations and converted this A to B. So if I have to convert, this becomes 1, this becomes 7, this becomes 2 and this becomes 9. Now what I'll do, I'll take one of the number. Let's say I take 2. Let's say I take 2 and I'll increment 2. I'll perform one up operation and increment to 3. Then I'll again do a down operation and I'll decrement 3 to 1. So in 2 operations, can I say I'll get back the same number? So do you understand that this 2 is an even? Now let's say my difference. Now coming back to my difference, what was my difference? 4. Now if my difference is even, can I say I can definitely perform k operations to convert A to B? So what will I do? I'll simply print yes. So one operation could be here if that is k minus min. Okay, let me take in a variable. Let's say int difference equals to k minus min. Now one case would be if the difference is even, so that means I can definitely convert this A to B in k moves, exactly k moves. So I'll simply print yes. Now other case, what if the difference is odd? So what should I do? Now if my difference is odd, it is a case where we get stuck. Now let's come back to the problem. Now what did I do to find my minimum? I chose minimum steps in all the moves. Now let's say, now what could be other option here? I can take this one. So if I take this one, how many extra moves will I take? I already took one move. So my extra moves will be simply, I can take 7 extra moves here. If I decide to go in the larger path, I will take 7 extra moves. So I'll simply add plus 7. So here, if I take the larger path, my extra moves will be 3 because I already took 3 moves. So if I had to take this extra move, if I take this move, I'll add plus 3. Similarly, I took 4. If I had to take the larger path, I'll simply have extra 1 move. Now here, I can have 3 extra moves. Now these are nothing but my extras. Let's say this is my extra array which stores all the extra operations which will I get when I use the long path instead of the minimum path. Now do you understand that extras will always be odd? Why? Let's say my operation 1 is even. Let's say my operation 1 is even. My operation 2 will definitely be odd because we are doing 9 minus even, which will give me odd. Similarly, if my operation 1 is odd, then I'll get even because 9 minus odd will definitely give me even. So do you understand this part? Now do you understand my operation 1 will be either, if my operation 1 is odd, my operation 2 will be even. If my operation 2 is even, if my operation 1 is even, my operation 2 will be odd. So if this is even, this definitely will be odd. Now what am I doing? I'm doing max minus min. So do you understand that even minus odd or odd minus even will definitely give me odd value? So that is the reason why extras are always odd. Let's take an example such that I get the difference as odd. Now let's say my k is not 15, it is 18. Let's say my k is 18. So if my k is 18, what is my difference? My difference will come out to be 7. Let's not take 18, let's take 16. Now if I take k as 16, my difference will be 5. Now if let's say I chose this operation, instead of this, then my min will get incremented by 3. Now let me write the extras here, 17313. So let me write my extras here. So extras are 7313. Now let's say I decided to take long path in the first operation, in the first value, in the first dial. Let's say I chose this instead of this, then I'll have 7 extra moves. So if I take This one, if I consider here to take the larger path, my difference is 5. Then I have to subtract it 7. So is it possible for me to convert A to B in k number of moves when k is 16? No, not right, because 7 is greater than 5. So if I take this value which is greater than 5, I can never convert A to B with this many exact k moves. So 7 is not possible. What about 3? So if I subtract 3, this becomes 2. Now 2 is an even. If 2 is an even, I'm pretty sure that I can convert A to B with exactly k number of moves. Now what if I take 1? The same with 1 as well. We'll get 4. 4 is an even. We can also get exactly k number of moves. What about 3? Same with 3. Now do you understand that if my difference is D, now I have to take an extra move which should be the minimum possible move from the extra array. Now what is the minimum possible one? 1. Now if my D minus 1 is actually greater than or equals to 0, or in a simple case I will simply say if the minimum value from the extra array is actually less than or equals to difference, then I simply print true. Else I'll simply print false, because I know that if my minimum possible value from the extra array, let me change the extra array. Let's say my extra array is 7, 9, all 7s. Then can I take 7? I cannot take 7, right? Because the leftover moves I need are 5, but in my extra array, the smallest possible value itself is 7. So if my smallest possible value is 7, I can never convert this A to B with exactly k number of moves. I hope you understood the logic. So what is the other condition? So here, if let's say small represents the smallest value, here the smallest value, small is nothing but min of extra array. So I'll simply say if small is actually less than or equals to difference, then I'll simply print yes. Else print no. That's it. That's the entire logic. Let me revise it. So first step is to find the minimum number of moves. We'll find the minimum number of moves. Or will you take the minimum number of moves? We'll take the minimum of both the operations. Now we'll find the total minimum number of moves required to convert A to B. If the first condition is if the minimum number of moves is actually greater than k, so we can never convert A to B. So I'll simply print no. If they are equal, we'll simply print yes. If they are great, no. Here's the difficult part we need to come across. So we'll find the difference. If the difference is even, we know that, let's say 2, we can do a plus 1 operation and we can again do a minus 1 operation and get back the 2. So it takes 2 operations to get back to the same value. So 2 is an even. So we can perform the same kind of operations 4 times or 6 times or 8 times and so on. So if the difference is even, we can simply say, yes, I can convert A to B in k number of operations. Now, if the difference is odd, this is where we need to focus a little. That first thing is to find small value, or we'll get the small value from the extras arrays. I hope you understood how to get these extras. Extras are nothing but if I choose the larger path in any of the dials, the extra number of moves I need to do. So these are the extra arrays. So out of the extra array, I'll find a small value and I'll check whether the smallest possible value from the extras array is actually less than or equals to the difference. Then I'll simply print yes, otherwise print no. I hope you got the logic. Let's go and code it up. Alright, let's look at the input format. The first line of input will contain single integer t denoting the number of test cases, and each test case consists of 3 lines of input. The first line contains 2 space separate integers n and k, the number of days and k number of moves. Then the second line contains n space integers a1 and a2 and so on. Then third line contains n space integers b1, b2 and b3. So first you are getting the number of test cases. So let me take the input of it. So int t, then take the input of t, then run a while loop. Then in each test case you are getting 3 lines. First is n comma k, the size of the array and the k moves. Then you're getting values of initial dial and the final dial. So I'll simply store in 2 arrays. Then run a for loop. to take the inputs of this arrays. Similarly, we'll take the input of V array as well. Now done with the inputs. Now what is the next step? Now I need to find the minimum number of moves to convert A to B. Let me store it in a variable called mini. So I'll set to 0. So I'll run the for loop. Now int D is nothing but absolute value of A or of I. So one of the operation could be, okay, let's do one thing. Let's first find the difference and then type the operation. BRR of I. Now int operation 1 would be D, then int operation 2 will be nine minus D. So 9 minus D is my next operation. Now what should I do? Now my minimum operation would be int mini plus equals to min of operation 1 comma operation 2. Now I got the minimum number of operations to convert A to B. Now what is the first check? If mini is actually greater than the K. So if it is greater than K, what should I do? I'll simply print no, because we cannot convert A to B with K number of moves. Else, what is the first case? Let's find the difference first. So int difference equals to K minus min. So we got the difference. Now what is the first case? If difference is 0, or when will the difference become 0? When the K and mini are equal, or other cases if difference mod 2 is equals to 0. That is, if the difference is even. We got it right because we understood why difference is, if the difference is even, why it will be true. I'll simply print yes and then else. What is the other case? We need the smallest value from the extras, right? So did we find it? No. So let's find the small automatically. So let's say small is 0. So how do we find the small? SM is nothing but min of SM comma max of OP1 comma operation 2 minus min of operation 1 comma operation 2. So should I initialize my small with 0? No, right? I should initialize with the maximum possible value. So I'll simply take int max. So what should I do? If my smallest value, if my SM smallest value is actually less than or equals to difference, then I can simply say yes. Otherwise, the other case would be simply print no. Let's run the code. Let's look at the sample input and output. So for the people who did not understand how did I find the small, so what did I do was, now I know that at each step I'll get this value. How will I get this value? This is nothing but maxi minus min. So what is maxi? Max is nothing but maximum of operation 1 and operation 2. Min is nothing but minimum of operation 1 and operation 2. Now what I did was I initialized my small with int max. Now what I do? I compared this and this. Now which is small? 7. So I'll take 7 into my small. Now next I'll calculate this. How will I get this? Again max minus min. Now I'll compare 7 and 3. Which is small? 3. So I'll take 3. Next I'll get 1. I'll compare 3 and 1. I'll get 1. So I'll take 1. Similarly 1 and 3 I'll simply consider as 1. The same thing was happening in the code. So I inserted the small with int max. Then at each step I'm taking the maximum and subtracting the minimum to get the extra moves, and then comparing the extra moves with the small value and updating with the minimum of small and max minus min. That's it. So sample test case is working fine. So let me submit it. Yeah, it is working fine. So I hope you understood the logic and the code as well. So if you want, I can give an overview. So this was the input part. So I took the input. Then in the next step, what I did was I found the first operation, then the second operation. Out of them, I took the minimum number of moves. Then I also, in the meanwhile, I also found the extra moves, smallest extra moves at each step. Now, first case is if the minimum number of moves are actually greater than k, then it's straightforward and no, because we cannot convert the a to b with k number of moves. Now, other part could be if the difference is 0 or if it is even, we'll simply print yes because we know that it is possible. And another case will be if the small number is actually is less than difference. It is true because odd minus odd will give you even. So with the help of even, we can simply say it is possible to convert the a to b. Now other part is simply no. So I hope you understood the problem and the explanation as well. I want you guys to go ahead and code it up. Let's discuss the fourth problem. Can you reach? A certain mountain range has n mountains all along a line. The peak of the ith mountain is at height of hi. It is known that adjacent mountains' peaks differ by height exactly 1. That is h of I minus h of I minus 1 equals to 1 for every I. On each mountain peak lives a single person. A person can move from one mountain to another adjacent mountain peak. That is either I minus 1 or I plus 1. However, they can refuse to move to a mountain that is of same height as one that has been visited before. Now, this is an example. We'll be discussing the example. Now, two people are considered to have friendship between them if they can both share the same mountain via some sequence of moves. What do you have to find? Given the heights of the mountain peaks, find the number of friendships. Okay, let's try to understand the problem statement. So, basically, you are given an array which represents the heights of the mountains. So, let's say these are h1, h2, h3, h4, h5, and so on, hn. Now, each point represents the hill station. You can consider the hill station. Now, if I draw these hill points in form of hills, it would look like something like this. So let's say these are the hills. Now, these points are nothing but, let's say this is h1, this is h2, this is h3, sorry, this is h3, h4, h5, h6, h7, and so on. Let's say there are multiple points on these hills. Now, on each hill, there's a person living on it. Now, what do we have to find? We have to find the total number of friendship groups. Now, what is friendship? A friendship is nothing but if a two persons share a common hill, if two persons shares a common hill, then they're said to have a friendship between them. Now, let's say I take this hill, a person living on this hill, and a person living on this hill. Now, can I have friendship among these two? Yes, because they share a common hill. Similarly, if I take person from here and I take a person from here, can they be friends? Yes, because they share a common hill. Now, what if I take a person from here and a person living on this hill? Can they become friends? No. Why not? P2, let's say this is person 1. And let's say this is person 2. Now, this person has to travel in this direction and this person has to travel in this direction. Let's say P1 reaches this point, then reaches this point, then this Y reaches here and reaches here. Then they have to reach here to meet. But if you look closely, this hill has been already reached by this person. Now, can this person reach this hill station of this side? No. Why? In the problem statement, they specifically said that they will refuse to move to a mountain that is of same height as one that has been visited before. Now, if P1 visits this mountain, let's say of height x. Now, can person P2 visit this mountain of height x? No, right? They cannot, because this height mountain x has already been visited by person 1. So, these two persons can never be friends. Now, I need to find the total number of friendship groups among the hill stations. Now, let's say all the hill stations are at single line. Let's say there are n hill stations. then how many friendship groups can I form? Can I say this person living on this hill will form friendship group with all the other persons living on the hills? Similarly, same with this, and then with this, with all the things. Then the total number of hill stations would be n into n minus 1 by 2 number of friendship groups. Now, instead of finding the friendship groups among all the hill stations, can I find the number of pairs which does not form friendship? Let's look into it. I know the total number of pairs will be n into n minus 1 by 2. Now, let's try to identify the number of pairs which does not form friendship. So, if I somehow find the number of pairs which does not form the friendship, can I simply subtract from the total number of pairs and get the total number of friendship? Let me redraw the hills. Let's say my points form these kind of hills, and let's say these are the points, these are the hill points. Now let's say I take a person P1 from here and I take a person P2 from here. Now can they form friendship? Yes, they can. Why? They will reach, they can visit here. They both can reach here, which is an unvisited one. Now similarly, if I take P2 from here, let's say P2 from here, and can this both form friendship? Let's see. P1 will come here, then P2 will come here, then P1 will come here, then P2 will come here, then P1 will come here, then P2 will come here, then P1 will come here, and P2 will come here. Now P1 and P2 will visit, they both will visit here at this hill. Now, is this hill already visited? I mean, is the height of the hill already visited? Yes, it is, because it has been already visited by P1 and as well as P2. So that means, can this both form friendship on this hill? They cannot, because the question clearly says that they will refuse to move to a mountain that is of same height which has been visited before. Since this hill of height x, let's say if the height of the hill is x, which has already been visited by P1 here and P2 here. So can they form friendship on this hill? They cannot. So do you understand that P2 can never form friendship with P1? Similarly, do you understand that if I take any person from these hills and if I take any person from these hills, can never form friendship, because these hills, the height of these hills are already been visited by P1, similarly with P2 as well. So I will consider this as my primary logic and extract the solution from it. Now, how can I say that they cannot form friendship? Now, do you understand that they can only form friendship if they share a common peak or dip? So if you take a person from here or a person from here, they will definitely form a friendship, because this is the one which is unvisited by both of them. So they will definitely visit here and they'll form friendship. Similarly, if I take any of the person from here and any of the person from here, they can form friendship on this peak or dip, whatever it is. Similarly, person from here and person from here can form friendship here and here as well. So I simply take all these peaks. So I'll consider these peaks. So let me say this is peak P1, then this is peak P2, then P3, P4, P5, P6, P7. Now they can only form friendship if they share a common peak. Now what we're trying to find? I'm trying to find the total number of non-friendship groups. So when they cannot form a friendship groups, can I say if there are at least two peaks between them, they will definitely not form a friendship. So if I take a person from here and take any person from these hills, they will definitely not form friendship. So that is my agenda. Now let's say these are the number of, let's say this is the number of persons here. Let's say the number of persons here as C1, and let's say the number of persons after this point are C2. So how many pairs, non-friendship pairs can I form? Can I simply say C1 into C2? Similarly, can I also take all these percents and can I take all these percents from here? We are having two peaks in between, and can I for sure say that all these pairs, all the persons from here can never form friendship with all the persons here? No, should I consider all these persons again? Not required, right? Because we already found the pairs by multiplying them with them previously. So we'll only consider these persons. So it will be, let's say this is C3, let's say this is C4, then it will be C3 into C4. Similarly, next for next peak as well. For the next peak we'll be doing the same thing for next peak and next peak and next peak, so on. So what is the first thing in my logic? Now, first thing was I'm trying to find the total number of non-friendship groups next. What we're doing, so to find the total number of non-friendship groups, what should I do? First step is to identify these peaks. So how do I know it is a peak or not? Can I say my P1 is nothing but P1 should be greater than, let's say this is X, index X, then it should be, let's say index I, then it should be, I should be greater than, let's say else of I should be greater than else of I minus 1, and else of I should be greater than else of I plus 1. Same here as well. For this one, what will you do? It should be _, of I should be less than _, of I plus 1, and _, of I should be less than _, of I minus 1. Let's say H is nothing but it is an array which store all my hill stations. Now first thing is to store the peaks and dips, so I'm just considering it as peaks. Next step is to find the total number of pairs, non-friendship pairs. Third is to simply subtract from the total number of pairs, which is the total number of pairs are n into n minus 1 by 2 minus, let's say these are minus this number of groups. That's it. So clear with the algorithm? Let's go ahead and code it up. Alright, let's code it up. Let's look at the input format. You're given t test cases, and in each test case you'll be given n, the size of the array, and then n integers, which are the heights of the hills. So let me take the input. So first I'll take t, then I'll run t number of times for the test cases, and in each test case I'll be getting n, the size of the array. So then we take a vector of type int, let's say hills of size n, then take the inputs of the hills, heights of the hills, hills of I. Now, what the first step is to, our first step is to find the peaks. We know how to find the peaks, so I'll take a vector to store the peaks. So let's say peaks. What I'll do, I'll simply run a for loop. I'll start my loop from index 1 and go till n minus 2 only, because I know my first one can never form hill peak, and the last one cannot form peak, because we are comparing with the previous and the next element. So for the 0th index and for the n minus 1 index, we cannot compare with the previous and next elements. So what was the condition? If else of I is greater than else of I minus 1 and else of I is greater than else of I plus 1, then if this is the case, or the other case would be else of I is less than else of I minus 1 and else of I is less than else of I plus 1. These are the two cases where you can get peaks and dips, so I simply push into the array. Peaks dot push back I. We did not take the input of the n, so let's take the input as well. Now what's the next step? Now I got my peaks. Now after getting the peaks, I need to find the answer. So I know that I am trying to find the total number of non-friendship groups. So I'll simply find the total number of pairs, which is n into n minus 1 by 2. So since we can have an overflow because n can range till 2 into 10 power 5. So I'll simply typecast it to long. Now I got my answers. Now I need to iterate and find the total number of non-friendship groups. So I'll simply iterate on the peaks array. So int I equals 0, I less than n minus 1. Sorry, peaks dot size minus 1 because we are taking 2 peaks at a time. So we need to compare with the next peak. So we'll be ignoring the last peak. So first is to find the C1. That is C1 is nothing but peaks of I minus. Now we do need a previous variable, right? Because for the first time we are trying to find C1. So this was C1, this will be C1, and all this will be C2. Now for the next time, all these are considered as C1? Not, right? Only these elements are considered as C1 and all these elements are considered as C2. So that means I need to maintain a previous peak as well. So for the initially previous peak was this, which is 0. For the next time previous peak would be this, and that next time this will be the next previous, and so on. So simply I'll maintain a previous. So I'll simply say long previous equals to 0. Currently it is 0. Then I'll simply subtract with previous. Then long C2 would be. So what are the remaining? You can simply get from n minus 1, which is nothing but total number of hill stations minus the peaks of I plus 1. So we'll get the total number of hills after the second peak. So we got this. Now what should I do? I need to subtract it from the answer. Answer minus equals to C1 into C2. And what should I do? I should also update my previous. So previous equals to current peak. Peaks of I. Simply print the answer. Let's run the code. We are getting an extra answer, so let's debug it. First step are the inputs, then peaks. Okay, we need to iterate till n minus 1. This is not n minus 2, n minus 1. And this else. And we also missed one edge case, we will be covering it up. This working fine. And one more thing we did miss was, now to find this C1 into C2 plus C2 into C3 into C4 plus so on, all these things can only be happening if we are having at least 2 peaks. Now if you don't have at least 2 peaks, then can I say this is what our hills will look like on a single line? So if you're having a single line, do I need to can I find this kind of answers on it? No, right? If I'm having a single line, that means my answer is n into n minus 1 by 2, because all these hills can form friendship groups with each other. So simply my answer will be n into n minus 1. So I need to apply only this if I'm having at least 2 peaks. So if peaks dot size is greater than 1, then we simply apply this logic. Otherwise it is not required to apply this logic. Run the code. Let's submit it. It got accepted. I hope you understood the logic. Let's revisit the code once again. So these are the inputs. So till here we got the inputs. Then we found the peaks. We understood what the peaks are. Peaks are nothing but dips and peak stations. So these are the conditions. It can either be a peak or it can be a dip. So I just pushed all the peaks into a peaks array. Then I am trying to find the total number of non-friendship groups and subtracting from the total number of pairs. So I need a previous because to find the C1. So C1 will be simply the current peak minus the previous peak, and C2 will be from the last hill to the peak plus 1. So with all these pairs, we can simply find the total number of non-friendship peaks. So I'm simply separating from the total number of pairs and updating my previous. I'm printing the answer. That's it. That's the entire code. I hope you understood the code. I want you guys to go ahead and code it up.
That's it for today, guys. I hope you learned something new from this video. If you like the video, make sure you hit the like button and share with your fellow coders. And don't forget to subscribe to the Smart Introduce YouTube channel.